from the couch, and today is March 6th. And with me, we have the EKS service team because today we're going to be talking about EKS Auto. And a lot of people have been asking me and the team of how do I start with EKS Auto? What is it? So I talked to the team and said like, hey, folks, let's get together and let's show people actually how EKS Auto works, what it is, and how to get the maximum value out of it. So with me, I brought in Alex and Todd. So Alex, can you want to introduce yourself?
Yeah, hey, thanks, Carlos. My name is Alex Kestner. I'm a product manager on the EKS team, and specifically, I work on all of the compute features for EKS. So these are things like EKS Managed Node Groups, the open source Carpenter project, and now EKS Auto Mode. So really excited to be here today, tell you a little bit about the feature that we launched at reInvent last year, and have Todd show you what Auto Mode actually looks like in practice.
And you mentioned a key topic there, Carpenter. A lot of people are like crazy about like using Carpenter, learning about more about Carpenter, how to maximize for cost, and that's a key element of EKS Auto that we're going to be learning about. So, welcome, Todd. Tell us about where you are located and
Yeah,
what you do.
my name's Todd Neal. I'm an engineer on the EKS service team. I work with Alex and a lot of other talented people to sort of help deliver EKS to our customers. Specifically, I've worked on things like Carpenter and now EKS Auto Mode.
So you do the hard work, the to the keyboard. And answering a lot of technical questions that come from the field, actually, that you ask us, but then we turn around and we ask Todd, like Todd for the specifics of like why is this works like this, and Todd had pulls from his time to answer field questions through a lot of like solutions architect and the people that work on the field. So we thank Todd for that.
I also do the same thing. I leverage Todd as an amazing resource, as
Yes,
well as the rest of the team, who's incredibly talented.
I double dipping. Okay, so Alex, tell us EKS Auto. I think it came out in reInvent, right? It's a big thing that our customers are like asking us every week. They're asking about like how they start using EKS Auto.
Yeah. So this was a really exciting launch for the EKS team at reInvent this past November. Really excited about the response that the features had. And I think for those that aren't aware, I'm happy to share a little bit about why we built Auto Mode and some of the things that it can offer to customers looking at Kubernetes on AWS. So, we have a lot of customers that choose EKS specifically because they want to leverage the open standards of Kubernetes and kind of the rich ecosystem of tooling that's available, combined with the security, scalability, and availability of the AWS cloud. Kubernetes gives customers a ton of control over the way that they can operate their applications. But the reality is that it's a fairly complex set of tools. And managing all of the components that are required for production grade Kubernetes applications can be challenging and take a lot of work. So EKS has always offered a managed control plane for Kubernetes clusters. This is kind of the foundational value proposition of the service. But what we would hear from from customers over the last 7 years as we had folks start to use the service is that they really would like us to bring that same fully managed model to not just the control plane, but also the data plane of their clusters where applications actually run. These are things that customers would have to do themselves today. Various infrastructure maintenance tasks, selecting and provisioning compute, maintaining various kinds of Kubernetes plugins for auto scaling or networking, storage, et cetera, and then patching all of those and the underlying infrastructure to make sure that they stay up to date and secure. Now, they also have to do all of this while looking to optimize costs and deliver the most value for their organizations. And with this feedback we kind of took that in and kind of collected a bunch of it. And this is where Auto Mode really came from.
Great. And for customers that want to get started, like do they need to start with creating a new cluster, or this is something that they can add to their current clusters? A lot of our platform teams have a lot of EKS clusters already.
Yeah. So one of the things that we knew needed to be true for Auto Mode was that it had to be something that customers could adopt gradually. customers at either large organizations or organizations with a lot of different applications running on their clusters know very well that different applications have different levels of maturity and readiness for new tooling or different kinds of innovations in Kubernetes and from AWS. So one of the things that was that we knew from early on as we were thinking about what auto mode might be is that it had to be something that you could introduce gradually into a cluster. And so auto mode is a capability that you can enable in any existing or new EKS cluster and run alongside kind of the standard, let's say, model for how you would previously had run would manage the data plane of the cluster. This way, you can migrate workloads over to auto mode as they're ready, and leave perhaps older workloads, things that need a little bit more care and feeding on standard infrastructure within the EKS cluster.
And then for folks that are joining, we are talking about EKS Auto. Some folks already putting where they're located, watching us live right now. And if you have any questions as we go along, please put them in the comments, and then we'll ask the experts here. So, and yeah, tell us where you're watching from. And if you're already using EKS Auto, right? There's already people like in production. You can use EKS Auto, right, Alex?
Yeah, that's right. Really excited with the response to the launch. It was one of the most popular launches at reInvent this last fall, and we absolutely have folks that have adopted this, starting to use it throughout every stage of their journey, from testing it out, seeing if it's a good fit for them, to using it in production already. So really excited with the response that we've seen.
And it's available in most regions.
So it's available in all commercial AWS regions, and the sort of availability in the US GovCloud will be coming later this year.
This morning I was working with a GovCloud customer, and he was asking me like, when it's going to come into GovCloud? Like, there's always the ask for that. But it's a reason that they come last, right? It takes more effort and due diligence to get it to GovCloud.
Yes, but having kind of all, this is true for AWS in general, that having all of the services and various features of those services available in all of the regions that we operate is really critical to providing that sort of that unified offering to customers, for their international or global workloads.
Yes.
So Carlos, it occurs to me that we haven't actually said what auto mode is. I'd be happy to give like a little bit of an introduction, because we've talked about why we built this, some of the work that's coming up for us. But for those that maybe aren't as familiar, maybe it's worthwhile for me to speak a little bit about like what this is. I said a managed data plane, but what does that really mean, right?
Yeah, you mentioned that we want to solve that problem, but people have been using EKS for the last 7 years, and they have been asking us for solving this problem, but it's not as easy as just like we're going to take everything over, right? Because the reason people use Kubernetes in AWS and they use EKS is because of the flexibility, right? They want to run containers. They want to have the flexibility of using Kubernetes, which is a CNCF project, and the CNCF ecosystem, while maintaining an operational stand that is secure, high scale, and cost optimized. But there's a balance there. Like, if you're going to take everything away, then there's no flexibility. So it took some time to figure out like what is the right balance of what that share responsibility model, right? I think you're going to talk about like what is it? What is EKS Auto Mode? That is, we have EKS, and what is EKS Auto Mode?
Yeah. So this was absolutely something else that we knew early on needed to be true as we were designing auto mode. It needed to both be something that helped fully automate Kubernetes cluster management for compute, storage, and networking on AWS, but also gave customers the continued access that they'd want to the variety of Kubernetes ecosystem tools and sort of patterns that they come to expect when they adopt Kubernetes. We call this Kubernetes conformance. There's a series of tests that that kind of tell us whether or not a given solution
Upstream.
in the Kubernetes ecosystem, exactly, upstream test, whether it's conformant or not. That means that it works with all of the sort of Kubernetes APIs and other Kubernetes conformant tools, and that was something that we knew needed to be true for auto mode as we were designing it. So auto mode is meant fundamentally to simplify management of Kubernetes clusters by automatically provisioning the infrastructure that workloads need, selecting the optimal compute instances, and dynamically scaling them while also continuously optimizing costs. We don't just manage and provision. We don't just provision infrastructure. We also manage essential add-ons for Kubernetes clusters. Things like compute, storage, and networking plugins, let's say, so like a CSI driver or the VPC CNI, because these things are strictly essential for running Kubernetes in any kind of real world environment. With all of these kind of as another aspect to auto mode that we're really excited about is that we don't just manage these plugins for Kubernetes clusters, but we also manage the instances themselves. In fact, auto mode is the first feature to make use of a new operating model for EC2 called EC2 managed instances, whereby a customer can delegate to another AWS service, in this case, of course, EKS, the operational responsibility for the actual instances where workloads run. This lets customers leverage the scalability and operational excellence of AWS without having to be deep Kubernetes experts or bear the burden of ongoing infrastructure management. We hope that with auto mode, customers can offload all of the cluster operations that they want to AWS, get started quickly, improve performance, and reduce overhead, so that they can focus on building the applications that really drive innovation for their businesses and their customers, rather than having to spend time managing the clusters where those applications run.
And the data plane, like in EKS, the EKS service team have taken care of like in terms of upstream, and all the people follow us because of the open source upstream, like the worker, the control plane and the etcd, right? That's something that we have done for a while. But then we say bring on your data worker nodes and those operating systems with Linux. And then what customers tend to spend a lot of time is like, when do I patch them? Right? When do I upgrade the versions? If I'm going to upgrade the versions, is the version of the add-on that I'm using, do I need to upgrade it? Do I have to reserve some capacity? Do I have to have some nodes to run these plugins and add-ons that they're not business apps? They're just like there to do Kubernetes controllers, right? Run the Kubernetes controllers.
That's right.
Is that something that how do I optimize for them? Like, do I give them ARM? Do I give them AMD 64? How much memory and CPU do I give them? That's data planes that I need to allocate, and data plane that I have to patch and watch to make, if any restricted environments being compliant, is something that you have to patch X amount of days. It could be 21 days, like no more than 21 days. You have to patch your operating system to be compliant with certain regulations. That's something that we took into account.
Yeah, absolutely. So this is, you're right, that both the sort of the open source landscape of Kubernetes tools moves really quickly, as well as Kubernetes itself. They're releasing 3-ish versions a year, and the kind of burden of keeping up with all of those, and then the sort of like ripple effect of other kinds of components of a cluster that have to also be maintained really becomes challenging for a lot of customers, let alone the sort of continuous march of potential security issues or operating system updates. All of these things are things that AWS is happy to take on the burden of with auto mode. We see this as work. I went out and talked with a ton of customers as we were thinking about building auto mode, and universally they all told me that this work was pretty undifferentiated for them. It was just heavy lifting they had to do to get the benefits that they wanted to from Kubernetes. And we're happy at AWS now to be able to take that burden off of our customers' shoulders and do it for them. So that was absolutely kind of part of the rationale for us to build auto mode, and we think the benefits that customers will get when they adopt it.
Okay, so are we ready to see like how this EKS auto mode looks like? What we thought that you're happy to show us like how people can get started?
Yeah, I'd be glad to. So let's close this out, and we'll start with just creating a new cluster. People that use EKS today probably use EKS Cuddle or maybe CloudFormation to create clusters. But one of the things our team has done over the past year is really improve the console cluster creation experience. And so I'll just go create a cluster here. There's this new quick configuration option. It pre-populates all these fields. It picks a new name for my cluster. For the cluster role and the node role, so the role that EKS will be using to operate this infrastructure and the role that will be on the nodes themselves, it's identified that I've created these previously, and we can just reuse those. If I hadn't done that, I could click this button, and it would go create that role for me automatically. And it's picked a VPC that looks like it would work, and I'll just change to a different VPC that I have in my cluster, and that's basically it. The create button is highlighted. I can go in and expand the settings and kind of see what's going to go on or what's going to happen. And yes, this has got a default of EKS Auto Mode, but we'll just go ahead and click Create Cluster. And now my cluster is being created. So literally, click the button to create a cluster, pick your VPC, your roles, if they're already existing, they're already pre-filled, and your cluster is now in the creation process. It takes a few minutes for us to spin up the control plane for this cluster. So I will actually go to a cluster that I've created previously.
And I'll mention something about that wizard. Before that wizard, I used to create clusters with the console, and I had like the documentation next to it because I had to create the roles and then figure out what roles do I need to create. And now this wizard actually like makes it like a one click. Like if you don't have the role, you can click in there and it will create the cluster role with the right permissions, create the node role with the right permissions, where maybe in the past people were like trying to figure out like I had to do this in the console and then I do this in the docs and then I go here and then jump around. So we make this like streamline, like people don't realize like how it was in the past, right? On creating an EKS cluster, and you were not able to get to a working cluster. With EKS Auto, we're trying to get to the point that you want to deploy containers. Like give me a cluster with the best practice, good defaults out of the box, right?
Yeah, absolutely. If you sort of look at the improvements to the console to sort of streamline that experience, plus the new capabilities that EKS Auto Mode brings with you or brings to you, you get an out-of-the-box experience that's ready to go to deploy pods. And I can show that now. So I've got this cluster, and we'll go look at our nodes in the cluster, and there aren't any. We can go look at the pods in the cluster as well, and we won't see any.
Let me stop there because I think I told you this in pre-show. Like maybe this is for 7 years you have not been able to take an EKS cluster, do get nodes and get empty, right? You always had to have like chicken and the egg. You have to have nodes to run these controllers, to run core DNS, to run kube proxy, to be able to get the first, like this is the magic behind EKS Auto. Like you don't have workloads, business apps. There's no need for nodes. There's no need to pay for that data plane. There's no need to pay for instances. If there are no apps, it's your scale to zero. There's no apps running. You don't pay this extra overhead on it. So that's kind of like a magic thing that people don't realize. Like, yeah, you don't have nodes when you start with EKS Auto Mode.
So there's a number of innovations in behind EKS Auto Mode. One of them absolutely is that all of the things that will power kind of these like the essential Kubernetes cluster capabilities, compute auto scaling, networking, storage, et cetera. Many of these run outside of the cluster. And that's absolutely kind of one of the things that allows us to show you a brand new created cluster with no nodes. And then as Todd's gonna demonstrate, show you how we can very quickly get an application up and running without any other infrastructure management tasks.
Yeah. So if I know a lot of folks follow us and they're experts in Kubernetes and EKS. And they're doing it today. Basically, they deploy Carpenter, right? It's a deploy Helm chart. They deploy the application load balancer, another Helm chart, and they will have nodes running here. Carpenter will come in a minute, but go ahead, Todd, and show us how. Yeah, go ahead.
So I've got no nodes, but Auto Mode does give you the ability to automatically create some node pools when you create the cluster. And so I'll let it do that for me. So I have a general purpose and a system node pool, but you can see they haven't launched any nodes yet because I've got no workloads yet. So we'll just start by creating a workload. And so I'll just deploy this Helm chart. This is the retail store sample chart. So it's open source, it's public, and people can go install this on their own cluster if they'd like to. And it'll take just a few seconds to download and install this Helm chart. It's going to create, yes.
And one thing for the Kubernetes nerds, like I call my family like of Kubernetes nerds, CRDs, like you did get no pool. That doesn't come from upstream Kubernetes. That's a CRDs that are already installed. And like Alex says, there's a controller, right, that is manages those CRDs, but it's not in your domain of wariness, right? It's in our domain of wariness that I'm going to patch them. We're going to run them for you. So the CRDs are there and their controllers reconciling them. It's just you don't see them because it's something that you should not care about.
Yeah, so you can see that I've installed the Helm chart. I had the node pools that were empty, and on the top view we have the EKS node viewer there. And Auto Mode has already launched a couple of nodes to support these workloads and basically get them up and running. And so I can actually go look at
get nodes. You will see them.
I also have to give Todd a little kudos here for those that are EKS Node Viewer fans. This is a tool that Todd created and has sort of taken on a life of its own.
Yep.
I personally love it. I use it in the clusters that I run, as part of my day to day. And I know that a lot of folks that use EKS really enjoy kind of the visual view that it gives you into the compute in your cluster. Sorry, Todd.
Yeah, and if you have seen a lot of solutions architects giving you EKS demo, probably you recognize the tool at the top that shows you the pods and the number of pods, the number of nodes, and estimate on cost also. I think there's an option for that.
Yeah, and so I've deployed this demonstration Helm chart, and one thing I like about it is that it's complicated. It's got an ingress, it's got multiple deployments, multiple services, it's got some persistent volumes. So I can go look at this persistent volume claim, and it looks like it's already bound to a persistent volume, and I can go look at the persistent volume as well, and it looks like that's been created. So I've deployed this Helm chart, and it's created an EBS volume to act to basically provide the stateful storage for this volume. I can go look at my pods and we'll check those out and see if they're up and running. And so there's some dependencies between these different services. So some of them have to actually get running first, like you need the database running before you have the service that actually relies on the database. So there'd be a bit of crash loop back off, but within a few minutes, basically, we should see all these pods go running. And one other bit for this particular demonstration, it creates an ingress, and as part of auto mode, there will be an AOB created that will back this ingress. So this is now a public domain, and that's going to be routing to these pods that are running in my cluster. So I didn't have to install like an AOB controller or the CSI controller or the CSI drivers. All those come bundled with auto mode, so you can go directly from installing a Helm chart to a production-ready deployed application.
Yeah, those are three components that people used to install before EKS auto mode, right? So in this case, it's Carpenter. So we're handling that like a Carpenter equivalent, right? We're running the application load balancer controller. We're handling that for you for creating the ingress, and then the next one is the CSI driver for storage. And we're not using. Say it used to be a time that was was called upstream, like there was a version of the EBS. CSI controller inside Kubernetes. We're not using that one, so we're using the proper like latest code, proper one that is out 3. That if you use EKS Auto without EKS Auto mode, you have to deploy that Helm chart or the EKS add-on, like add-on to run it, but it will consume some pods. So in this case, 3 add-ons that are like invisible, right? They're just running there. You don't have to worry about like are they patch, what is the version, security. Are they running out of memory? Are running right? They're limiting resources. Like that's something that you don't have to worry about, right? The pod goes pending, you get a node. A PVC gets requested, you get your storage.
Yeah. So as you said, there used to be some in-tree controllers for the storage things, and then the upstream community has moved towards the outer tree controllers. The CSI controller that's part of EKS Auto Mode works the same way. It's an out-of-tree controller. But you're right, it sort of runs on our side of the fence. So we're responsible for ensuring that it stays healthy, that it stays patched, that it stays connected to your cluster and working. And as a consumer of EKS Auto Mode, you're just creating the things, the CRDs in your cluster to, create volumes, create ingresses, create pods, and we do all the sort of machinery behind that to ensure that we launch the correct compute, create the correct ALBs, NLBs, create the correct EBS volumes, and attach all those to your instances correctly. And so we've been
go ahead.
We've been running for a few minutes here, so it's very likely that our pods are all up and healthy. So we'll go grab that address, and we can just throw that in our browser. And again, this ALB didn't exist before I did that Helm install. And we now have a fully functioning store that's using a couple of different databases. It's using Redis, static volumes. It's fully functional and sort of ready to go.
Yeah, this is
for the record,
that we use in a lot of workshops. Go ahead.
I absolutely held my breath as Todd went to the load balancer endpoint. Nothing like a live demo.
Mm-hmm. Absolutely.
Yeah, load balancer takes a minute or two to come up. It's an appliance, right? That you delegate to us to AWS as a load balancer that gets created with the ingress. And this is a retail app that we use, and we have a cool new version. So maybe another show will bring Neil to show us the new version I don't know if there's a question on the chat. People are asking, where is this other stuff like core DNS, kube proxy, VPC CNI? Can we do a get pod dash A, capital A? We should be able to see them there, no? Because Kubernetes
you
doesn't
will
work without that.
Yeah, so you will not see those pods there. So I'm going to run kubectl get pod -a, and you're only going to see the pods that are from this demonstration application. So we actually take those components and package them into the AMI, the Amazon Machine Image, and then maintain them there. That lets us provide this sort of hermetically sealed package of the kubelets, containerd, run C, the CNI, the CSI, basically all these components that we've been able to test as a unit, run through the full upstream Kubernetes conformance test, validate, ensure that we keep patched, and basically lets us provide or at least have a level of confidence that, hey, all these things are compatible, they all work together, and they're all patched and ready to go.
And I feel like this
Yeah.
is one of the aspects that is sort of specifically related to EC2 managed instances. It allows us to provide a truly fully managed data plane, not just a set of fully managed controllers, but the actual places, the actual infrastructure where applications run. By having that kind of hermetically sealed AMI, it means that we're confident that customers can roll this out. If there's an issue, they can raise it to us. Although the reality is that the kind of like the rigorous testing that Todd's talking about and kind of the certainty we have about what software is actually going to be running on these instances is part of the way that we're able to deliver on the sort of the promise of a fully managed data plane.
So since we have EKS Node Viewer up here, it's always nice to create just a couple hundred pods and watch those pods get created in real time. They get scheduled to nodes instantly, and then auto mode works to see these pending pods, which can't fit on those nodes, and will then work to launch new capacity for those nodes. So it's launching a C6A 8X large, literally within a few seconds of me creating those pods that couldn't fit on my existing nodes. And it's going to continually optimize for cost of my cluster. It's aware of the prices of all these instances, and then optimize it to ensure that they can run as cheaply as possible.
And for Carpenter, this is where Carpenter comes into play, right? What's the component that is deploying these nodes, right? Instances, and doing it faster that probably maybe in the past was just in something else. Carpenter, for folks that are not familiar with Carpenter, can you talk a little bit about the Carpenter component? Like why so fast to get your nodes and your pods up and running?
Mm-hmm. And we actually see that auto mode has decided that one of those nodes is no longer necessary, so it's going to remove it and drain those pods and move them to the other node. So Carpenter is an open source project that we started several years ago, and it was sort of takes advantage a lot of the EC2 APIs for being able to request launching several instances amongst several types using different policies for pricing. And it's really built around launching the right compute at the right time based off the constraints of the workloads. So there's a list of requirements that we support. So you can basically go into your pods and say, I want this one to be on an instance that's optimized for network, or only of maybe a few different families. And it's able to basically look at the intersection of all those requirements of your node pools and your workloads and launch sort of the cheapest capacity, cheapest instance types that will satisfy that compute. And I can show an example of that. So I've got a pod.
Go ahead. Well, while Todd's pulling that up, I think one of the things that makes Carpenter pretty unique is that previous cluster autoscalers had this concept of like different groups of capacity with like sort of well-defined
Static.
sort of well-defined sizes, and it needed to know about these kind of predefined sizes in the groups so that it could pick which group to just simply like increment the capacity of. Carpenter, as Ty was saying, kind of does away with this concept and instead just looks at what the applications actually need and then goes and maps that across the vast portfolio of EC2 instance types to pick the most cost-effective instance to satisfy those requirements.
Mm-hmm. And so we have an example there right now. So I've created this pod, and we'll look at it when I describe it. And this pod is requesting a Neuron device. And we see from auto mode that it's failed to schedule. It's saying that It's incompatible with my system node pool because it doesn't have a toleration for the taint on the system node pool. And it's incompatible with my general purpose node pool because it's requesting this Neuron device, and the general purpose node pool only has CM and R instance types. And so basically, I'm at this situation where I need a new node pool that's capable of launching an instance type that has a Neuron device. And I happen to have one here that I'll just apply. And this is a really simple node pool. I'm reusing my node class, and I'm just saying, yeah, launch an on-demand instance type, but something from the Inf1 or Inf2 family. And that's literally it. And there happens to be a taint on here, so no other pods will schedule to these nodes. It's a good practice for these GPU and accelerator types to put a taint on them to sort of segregate your workloads. But I'll go create this node pool.
So I think this is another kind of interesting connection point with the open source Carpenter project. You saw Todd just created a node pool that, if you had paid kind of close attention to, had the same API group and version as the upstream or open source Carpenter project. We think of this as kind of a way for us to balance the sort of ease of use and manage nature of AutoMode with the compatibility for all kinds of open source or upstream tooling. That node pool API is effectively our contract with the open source Carpenter project. And I was talking earlier about how one of the things we had to figure out, we decided very early on with AutoMode, was that it needed to be Kubernetes conformant. We made a similar decision with that Carpenter dependency, that we needed to be able to honor that kind of full node pool API specification within EKS AutoMode.
And that's the reason a lot of people were asking us, like, when Carpenter's going to be V1, right? Last year, like, when it's going to be V1.
Yeah.
And we wanted to make sure that V1 was a contract that was stable enough that we were able to give you that contract in EKS AutoMode. So in all respect, or strict speaking, like, batteries included. Like, people were asking us, like, well, Carpenter is so great, can just like come out of the box with EKS, right? If that's what you're pushing as best practice, the best tool to optimize. So if you're using open source Carpenter, it will work the same way here. You create your node pools, you can have weights, you can even have try to use Spot, right? Try to find a spot, and if you don't find a spot, use an on-demand. So it's Carpenter all the way. Like, it's not different from using open source Carpenter. But those managed instances will be managed for you, right? It will be not be instances that you are handling.
One of the other things that having Carpenter have graduated to V1 or to a stable version is that it also makes it easier for us to upgrade that seamlessly behind the scenes. This is true for all of the other controllers too that AutoMode runs on your behalf, is that because they're all they all have stable APIs and are mature products, it's that much easier to kind of continually roll through any updates that they may have.
Yeah, and the node pools, as somebody asked, asking, like, EKS Auto comes with 2 recommended node pools, right? But if there's enterprises or that want to create their own node pools, or they're already using open source Carpenter and they have like 15 node pools, right? They can just bring them along and then use those that are specialized. And usually people, these are a starting point, right? Like Todd said, like they don't have GPU out of the box, so you have to create your Carpenter node pools following the Carpenter best practices on configuring on the consolidation, or the picking a lot of different instance types in terms of spot, right? To have like better chance to get a spot.
Yeah. So we absolutely expect that customers will perhaps get started or try AutoMode with some of the built-in node pools, the general purpose and standard ones or system ones that Todd showed. But in sort of a more real-world scenario, or if they're already using Carpenter, I would absolutely expect that they would then migrate or kind of duplicate those node pools for AutoMode.
Yeah, and so I can even show that a bit. So we launched that Neuron pod that requested a Neuron device, and the pod went pending because it didn't fit our 2 standard node pools, and I had to go create a Neuron pool that could support the Inf1, Inf2 types. And so what's happened is I've now got an Inf1 X large, my Neuron pod is running, but it's more than that. It's not just that it's running, it's that the Neuron drivers are installed, the Neuron device plugin is installed, the EFA plugin is installed. All of those necessary components to get that workload up and running are also part of that. And we can see that by looking at the node. The 2 standard nodes are running the BottleRocket EKS Auto AMI, but EKS AutoMode basically identified that, hey, this pod is requesting a Neuron device, so I need to launch a Neuron instance type. And when I launch that Neuron instance type, I need to give it the Neuron AMI because it also needs those other components that are required to take full advantage of the accelerator hardware. And so that's what it's done. And now my pod is able to run and use that accelerator hardware just out of the box without me needing to go worry about versions and compatibility or do installs of device plugins or anything like that. It just works.
So out of the box, it works also for NVIDIA, right? So you have one NVIDIA GPUs. We have Bottle Rocket, and the first time we mentioned Bottle Rocket, a lot of people ask us about AMIs, the operating system. Like, do you want to tell folks like what is Bottle Rocket and the type of AMIs that are supported?
Yeah, so one of the things that's been really interesting about auto mode is that EKS has been running tens of millions of clusters for customers over the last 7 years or so, and over that time we've developed a really sort of deep set of best practices, kind of things that we've both learned from customers or that we've kind of discovered ourselves about the kind of the best way to run Kubernetes in a production environment. And Bottle Rocket is kind of one of these relatively newer tools in this category. It's an operating system, it's a Linux operating system, but that's specifically built for containerized workloads. If you think about a general purpose operating system, there's all kinds of tools that come packaged in that operating system that are helpful for working directly on that instance or doing things that are a little bit more sort of have a little bit wider variety. But Bottle Rocket is focused on one specific thing and doing it as well and as performantly as it can, which is running containers. So when we started to look at all the best practices that we had about running Kubernetes and the data plane specifically, Bottle Rocket was an easy choice for us to use as the base operating system for auto mode. It has a ton of benefits, not just for for our customers in terms of security and performance, but also for our team, who is effectively responsible for all of these instances that are running under EKS auto mode.
And so these instances, I know we talked about it earlier, they're managed instances, and they're a little bit different than your sort of standard EC2 instance in terms of the operating model. And I'll demonstrate some of that. So I've got this handy script here called breaknode. And you'll see what it does is it tries to remove the instance profile from the instance. So that's what links the instance to its role. It then tries to go ahead and just detach the root volume from the instance, and then finally, it lists all the ENIs and tries to detach all of those from the instance. So it's trying to detach it from networking. And then as a sort of last step, it just tries to terminate the instance. So multiple ways that if you ran this on a sort of your standard EKS cluster with an instance that was not an auto mode managed instance, it would cause some problems. But no fear, during a live demo, I could just ask it to break one of these instances that are in my cluster. And it's going to say that I'm using the admin role for this account. It's going to go try to remove that instance profile, and it's going to get a permission error. And I could decode that and see some more information about that. It's trying to detach the root volumes. It's now trying to detach all of the ENIs from that instance. And then as a last step, it's finally going to try to terminate that instance. And all of these things fail. Because this is a managed instance and we've taken over responsibility for it. So you can interact with the instance, but you interact with the instance through EKS, through letting it be a Kubernetes node in your cluster. And there are also some changes to how it actually looks in the console as well. So if I go over to the EC2 instances in my console, I can go find this particular instance. And we'll see that there's a new field here. This one has an operator of eks.amazon.aws.com or aws.com, and that lets you know that, hey, EKS is managing this instance for me. In addition, there is a flag here on the instance that shows that, yes, it is a managed instance. And the same data shows up if you use the AWS CLI or the AWS API to call describe instances. So you can distinguish an instance that's being managed by EKS versus any other normal instance in your account.
Says this means that security, like that's something that the customer doesn't have to worry about, like patching for CVEs or keeping up to date with patches, and like a lot of people like configure like to get notified when new AMIs come out that they have to like roll out their patches. So how should that work in EKS Auto?
So for EKS auto mode, yes, AWS is responsible for the machine image that runs on the instance and for rolling out that machine image. So if I look at my nodes now, basically, we roll out a machine image roughly every week. This machine image was created on March 2nd, so it's just a couple of days old now. So it has all of the CVE fixes for kernels or the Linux kernel or any other component that was updated in that time. And yes, we basically use the standard AWS best practices for software rollout. So the same mechanisms that we use to roll out within a single region and roll out slow and then roll out in larger waves as we get more confidence. We follow those same best practices for rolling out Amazon Machine Images for EKS Auto Mode. That lets us get confidence in images after they've already passed all of our rigorous testing, our internal testing procedures. We roll them out slowly, we get more confidence, and then we sort of open up the aperture and then roll them out more quickly to get the CV patches into the hands of customers.
I think one of the things that's important to mention too is that you as a customer can have some control over when nodes in your cluster are rotated in response to either a new AMI version or in response to various kinds of other actions that AutoMode may take. This comes through from open source Carpenter. There's a concept called, and I suppose also the open source Kubernetes project itself. There's all kinds of like pod disruption budgets or Carpenter disruption controls that you can set that'll help you manage how change to the infrastructure in your cluster happens, how and when. And this is kind of part of the balance that we're trying to strike with AutoMode is taking over a lot of the operational burden of maintaining this data plane, but giving customers enough control over how and when some of that happens, so that their applications can remain as available and healthy as they may be able to.
Yeah, they can define things like a window, right? They're saying like from Monday to Friday during the day, I want zero disruptions, right? They put the budget, and that's something that is in the, I would say open source Carpenter, but the open source Carpenter API, right? That the same configuration you can put in there. So these nodes will be replaced. So Carpenter, the same way as Carpenter open source, would respect those PDBs and then give you a grace period up to 24 hours, for example, and enforceably get you out. So you have to design your pods that you can have your PDBs, right? You have to have enough instances to handle the traffic, or also even when updates happen, you can do them in batches, right? Like do not do more than 10% updates at a time. What happens on this cluster dot? It says 1.31. If I upgrade my control plane to 132, like how those upgrades happen for this data plane to 132?
Yeah, so the data plane that EKS Auto Mode manages will follow your control plane version. So if you update your control plane version from 1.31 to 1.32, using the same PDBs, the same no disruption budgets, those same controls that you have to control the regular AMI rollout, those will be used to move you basically to the next version of the AMI so that you will have a matching version of kubelet, kubeproxy components on your data plane nodes that match your control plane version. So basically, all those things that we manage, we ensure that they're compatible with your control plane, and we ensure that they follow the version of your control plane.
It's worth mentioning one other aspect of AutoMode that I think is a really critical security feature, particularly for customers that are operating in like regulated or high compliance industries, which is that there's a maximum lifetime for the managed instances that AutoMode launches, and that's 21 days. The reality is that when you couple that maximum instance lifetime with this sort of control plane following behavior for upgrades, it effectively makes upgrading your Kubernetes cluster running AutoMode a single click. You upgrade the control plane, and then at the very latest, within 21 days, your whole cluster will be upgraded to the next Kubernetes version. Really takes a lot of the toil out of Kubernetes version upgrades.
In terms of BottleRocket, so the biggest benefit of using these AMIs, right, comes with all the software that now AWS is responsible. So we can enumerate them, right? And BottleRocket is a container OS that is, the purpose is like kernel, container D, and you run your container. But to get it running in EKS, we provide that software that is extra. So for example, Core DNS will be one of them, right? It runs on that AMI, kubeproxy, VPC CNI, and then all the software that is required for GPU workloads, accelerators, right? Either Neuron or NVIDIA. and I believe there's one more called node repair.
Yes,
And what is node repair?
there's a node monitoring agent, and it's also available for non-auto mode clusters. But the node monitoring agent basically is built on the many years that we've been operating EKS clusters. We've identified a lot of conditions and failure modes that can happen to clusters. Things like you've got some container that's actually leaking process IDs. So there's a finite amount of process IDs configured in the kernel that you're allowed to have on that instance. And once you exceed those, well, now you can't launch any new processes. And once you've hit that point, basically your node enters this bad failure state. Things like exceeding, using up all your disk space, using all the inodes on the disk. There's basically all these failure scenarios. And so this tool is built to look for signals of those things occurring, report them on your node as Kubernetes conditions or Kubernetes events. And in the case where we know enough about that failure mode that we can repair it, we'll actually automatically repair that instance for you. So like in several cases, the cleanest thing you can do is basically launch a replacement instance and then migrate those workloads gracefully to the new replacement instance.
Okay, and one of the other questions that people ask, and I think this was on LinkedIn, people run some certain software, security software, that maybe they be using L23 and they want to move to BottleRocket. They ask like, there's security software that I run on Amazon Linux 23. How do I run it in BottleRocket? Like, what's the suggestion there?
So I think the key thing to recognize is that a lot of these like security scanning agents also have Kubernetes deployment models. So they could be run as daemon sets in a cluster. And because auto mode is fully Kubernetes conformant, all of these security scanning tools that can be deployed in a kind of a Kubernetes native fashion will just continue to work with auto mode. You may not have access to like the actual AMI that's going to be running on these instances, but for the vast majority, if not all of the agents that I'm aware of, there's a way to run them in a kind of Kubernetes native fashion, which can help kind of meet that security or compliance requirement that you might have. The other thing I'd mention is that because of the model for EC2 managed instances and auto mode and the responsibility that AWS is taking on with this feature, there's also, you don't need to take on as much responsibility for security and scanning or patching these instances. So for a lot of times, when we go and we talk with someone in a central security team at an organization and we explain this new model, it ends up becoming clear that actually they can do a lot less than they had to do previously with either a general purpose or standard infrastructure in their clusters. And the combination of those two like answers often are very satisfying for both the platform teams building an EKS and security teams trying to keep those organizations secure.
Well said. So we are running out of time. I think we cover a lot of ground on, and we have a lot of people asking questions. So if let me share my screen to share a call to action for folks. And I think people were asking in the comments about like a workshop. How do I get my hands on EKS workshop? You can scan this QR code. I think Sai has the link in the comments. There's many events that are remote in time zones in Europe, time zones in the US, and also in-person events that you can attend and get a hands-on free account. We spin up free accounts for you to attend. You get an EKS cluster with auto mode, and then go through a different exercises, and that would help you work with EKS auto. Even if you're already using EKS, there's scenarios where like migrating workloads are running in EKS, and then you enable EKS auto mode to run into there, from creating starting a new application like Thoughts application. Actually, that's the one that we use in the workshop for teaching you how to configure the storage, the networking, and how to configure the window. Like we mentioned, the window of like not allowing the budgets to upgrade and then upgrading. So
Yep.
all those scenarios are in those workshops, and then solutions architects and specialists like myself in different countries will be able to answer all your questions and get hands-on on the workshop. So with that, go ahead and sign up for one of those events. Alex, Todd, any parting comments?
Yeah, I'll take this opportunity while we're talking about the workshop to mention for anyone attending KubeCon EU this spring, there's also going to be one of those workshops live at the conference. So feel free to, you should be able to see some of the details about the EKS team's involvement in KubeCon EU. And so that's another great opportunity if you're going to be in the area to get a chance to get hands-on with auto mode and with some of the experts from AWS.
We have that link in the comments. Myself, Saya, and others will be there in KubeCon EU London, April 1st that week. And we also have AWS booth number 300, and we'll have EKS auto mode demos and other type of demos around operations, observability, simplifying Kubernetes operations on AWS. So with that, folks, I hope that this was a good show for you to learn about EKS auto mode. Reach out either in the comments or through the links that we provided you. And we'll see you on the next episode. Thank you, Alex and Todd. Very well demos today. Demo goes well on our side.
Great. Thanks, Carlos. Thanks, everyone.
Yeah, thank you.